Hey everybody, this lesson is going to get you ready for the IM1 test on Unit 7, Module 16 and 17, which is on transformations and congruence. So our school is skipping Module 18 for right now. We're doing 16 and 16, 17. So why is the midpoint of segment ST? Segment ST is not shown, so we'll draw it, you guys. I love pictures. Okay, here that is right there. There's a y right there in the middle. Okay, here's y being the midpoint of this segment ST. Okay, now it says if SY, now if it's the midpoint, then this piece equals this piece. Okay, so that's what midpoint does, cuts it into two equal pieces. So if this says if the measure of SY is 7.2x, let's put a 7.2x in right there and a 7.2x in right there, okay? Because it's the midpoint, it makes them equal, okay? Now it's asking what is the length of this guy right here, ST. That's what this says. What's the length of ST? Okay, so by the segment addition postulate, this piece plus this piece equals the entire piece. Okay, so what we're going to do is let that be there and just add them together. 7.2x plus 7.2x is 14.4x. Okay, that's your answer. Okay, so name the definition, postulate, or theorem that we use, the segment addition postulate. Whoops, I went too fast. Sorry. I have a mouse that double clicks sometimes. Okay, so name the new coordinates of f prime, g prime, h prime, I prime in the figure transformed right there. All right, what I need to do first, you guys, is I need to get all of these ordered pairs right there. So f is to the left 4, up 4, negative 4, 4. Okay, g is to the left 2, up 0, negative 2, 0. H is to the right 2, down 2, so 2, negative 2, and then to the right 4, up 1, so 4, comma 1. So there's all the ordered pairs, okay? Now what we're going to do is we're going to do all of these movements. We're going to change the sign of the x coordinates and then take half of the y coordinates, okay? So all of these points right here, that's what we're going to do to all of them right there, okay? All right, let's do the x's first. So we're going to go just change the sign. So negative 4 becomes positive 4. Negative 2 becomes positive 2. Negative 2, negative 4. Okay, so that's the new x coordinates right there. And then for the y's, you guys, what we're going to do is just take half of all of these. Half of 4 is 2, half of 0, 0, half of negative 1 is negative 1. I'm sorry, half of negative 2 is negative 1, half of 1 is a half, okay? All right, so here, is this a rigid motion? And explain. Well, it's not because of the half part right here. This little half part right here says we're going to compress the figure. It's going to be half as big, and since it's with the y, it's going to be vertically compressed. Okay, y is an up and down movement, so it's vertically compressed. In fact, if we graphed it, you'll see that it's not only vertically compressed, but it's reflected over the y-axis. Okay, so can you see this original figure being flipped over? And it's half as big right there. Okay, so it's being flipped over and half as big. Okay, all right, let's go ahead and get started with the next piece right here. Okay, so draw the pre-image of triangle TUV under the transformation XY equals x plus 1, y minus 3. Okay, so let's go ahead and graph these 3 points. Okay, so we're going to go over to the right 2, up 1. U is going to be 0, negative 1, and then 3, negative 3. Okay, so there's that figure right there. Okay, and then number 6 says, oh no, I'm sorry, we're not even on number 6 yet. So now we got to do the transformation. So what we're going to do is add 1 to all of these x's, 2 plus 1, 0 plus 1, 3 plus 1, and then subtract 3 from all the y's, 1 minus 3, negative 1 minus 3, negative 3 minus 3. Okay, so let's do that. There's all the plus 1's to the x's, there's all the minus 3's from the y's right there. Let's go ahead and graph those. Those are going to be t prime, u prime, and v prime. Okay. All right, now can you see that plus 1 with the x means goes to the right 1, down 3 or minus 3 with the y's means it goes down 3. Look at this, can you see this blue triangle just went to the right 1, down 3? Can you see that? So draw, now it says number 6 says draw a reflection over the y-axis. Okay, here's the y-axis. So this u prime is going to go right here to be u double prime, or u double prime. this t right here is going to go straight over 3 units over, so we're going to go 3 units over. There's t double prime, and then v double prime is 4 units over, so here go 4 units over. That's going to be v double prime right there. Okay. Now I think on your actual test it says reflect the red triangle over the x-axis. So if we set it over the x-axis, this goes up 6, so we're going to have to go up 6, okay, and so on. So this is the x-axis right here, and this is the y-axis, so just be careful when you're doing that, okay? All right, so reflect A, B, C, D across the y-axis to A prime, B prime, C prime, D prime, okay? So A prime is 5 units over across the y-axis. Here's the y-axis right here, so we got to go 5 over here. B prime is also 5 units, so 5 units over here. C prime is 2 units away, so we're going to go 2 units away right here. And then 1 unit away. Okay, so there it is right there. Now number 8 says reflect A prime, B prime, C prime across the x-axis. Okay, so now this is the x-axis right here. So this is going to go, here's 5 up above, so go 5 below. Okay, same with C, go 5 below. This one is 4 ups from here, so to go over here, we're going to go 4 down. And then A is just 1 unit away, so I'm sorry, A prime, and then so A double prime is going to be right there. Okay, sorry about that. So there it is right there. What type of rotation is A, B, C, D? So what type of rotation is the original figure, this guy right here, to this guy right here? Can you see they're kind of just curved over? In fact, I'll show you that right here. Watch. Look, if I just flipped it upside down, can you see the original figure and the red figure are just in, they're the same place? So if that's the case right there, if I can flip it over where this guy becomes this guy, and I'm just flipping it over right there, then that is a 180-degree rotation. Which way? Yes, it is. 180 degrees. Okay, so here we have ray SV, and is an angle bisector of angle RST. Okay, so I'm going to draw a picture. There's no picture on your test. You got to draw it. So just draw a generic angle RST, and then draw right up the middle ray SV. Okay, S is the vertex. All right, always the vertex where the angle is this middle letter right here. So RS is the vertex, and then T right there. Okay, let's do that real quick. Let's plug that in right there. Okay, so here is ray SV going right up the middle of angle RST. How big is that angle? Yes, it is. It's that big. Okay, just draw a generic angle, and then draw a ray that goes right up the middle. Okay, now here it says RSV, so RSV is 7x plus 7. I'm going to write that right there. And then it also says VST, so VST is 10x minus 2. So I'm going to put that in right there. Okay, and then so now since it's an angle bisector right there, whoops, I'm sorry, I've got my cursor over here. My new mouse is giving me creepy things here. So anyways, to me it's just frustrating. So if it's an angle bisector, this arc right here is going to equal this arc. So I'm going to put another red arc right there, okay? All right, and so since they're equal, then we just set those two expressions equal to each other. Okay, so here I'm going to go minus 7x minus 7x. 10x minus 7x is 3x. And then here we're going to go plus 2 plus 2. Whoops, darn mouse. I'll do this with my, if it'll let me. Okay, so we get x equals 3, and that's what it said. So 7 plus 2 is 9, then divided by 3 is 3. Okay, all right, so you have a couple that look like this. It says if the measure of angle IJK, okay, here's angle IJK, just follow the letters. So angle IJK, so that's the big angle. That's this whole angle right here. If that's IJA, whoops, IJA, sorry. It says that I'm sorry, AJK, that's this one, sorry, AJK, sorry, is 61 degrees, and then it says IJK is 153 degrees. Okay, let's put that information in right there. Okay, so it says it says that this angle is 61 and the entire angle is 153. Okay, from the angle addition postulate, I can say this angle plus this angle equals the whole angle right there. Okay, so 61, I'll call this little guy x, which is what we're looking for. IJA, we're looking for that, so I'll just let it be x right there. So 61 plus x will equal the whole angle, 153 degrees. Okay, so if we do that, there's our expression by the angle addition postulate. And so now what we're going to do is subtract 61 from both sides, and that's going to get us IJA, because that's what x is right there. Okay, so we get it to be about 92 degrees. Not about, but exactly. All right. Okay, so you can hear my dog Lucy playing in the background. She's got her baby, and she's shaking it around trying to get my attention. Okay, same kind of problem right here. Can you hear that? She's just trying to get my attention. Anyway, okay, let's do this again. She's going to have my attention as soon as I get done with this. Okay, so it says find the measure of the big angle ABC. Okay, so this says right here ABC. So find ABC if ABC equals the expression 17x plus 8. So I'm going to put a big arc all the way around 17x plus 8, and it says ABK. So ABK is 42. We'll float a 42 in there. And then KBC, that's what this says. KBC is 2x or 12x minus 4. We'll put that in there. Let's do that real quick, okay? All right, and again, from the angle addition postulate, I can now say that this piece plus this piece equals the whole piece, the whole angle right there, okay? All right, let's combine those like terms, 42 and 4. Minus 4 is 38. And then we're going to go ahead and, what did I do? Which there's several ways. Oh, I subtracted off the 8 and I got 30. Now I'll subtract off the 12x, and we get 30 equals 5x. I went one too many. I guess I didn't. So now it doesn't say find x on this, so be careful. It says find the measure of angle ABC. So we have to plug in x right here, okay? So this is not the answer, okay? It's tricky. It says find the measure of angle ABC. So they tell me that ABC is 17x plus 8. So we'll plug a 6 right there. 17 times 6 plus 8 is 102 plus 8, so we get 110 degrees, okay? All right, here we go. So in the figure, NL is 2x plus 5, LK is 3x minus 8, and let's look at that right there. So it says NL is 2x plus 5, LK is 3x minus 8. We'll put those in there. And then the whole piece, this whole piece from here to here is 32, okay? So that's what we're going to put in there right there. So we get that figure right there. And then by the segment addition postulate, we can now say that this side plus this side equals the whole piece right there, okay? And then we'll combine like terms and then solve for x, and we get x equals 9. And remember, it's not solving for x. My cursor is going too fast. So x equals 9 from all of this action right here. So it says find LK. Okay, now if you're taking any kind of state test, like an SAT test, 9 would be one of the multiple choice answers. They like to trip you up. And so let's plug in 9. We're going to plug in 9 for LK, so 3 times 9 minus 18. Let's do that right there. 3 times 9 minus 18. 3 times 9 is 27. 27 minus 18. Well, it's coincidence that the same answer is what x is right there. Total coincidence. Okay, so segment AB has endpoints 4, -4, and -6, 4. Find the midpoint. Here's the midpoint formula. Okay, my students need to know that. You need to have that memorized. You're going to see that again in IM2 and again in IM3 and pre-calculus and calculus. So I'm asking you guys to memorize that right now. Same with distance formula, okay? All right, so here's my x1s and x2s right here. I'm sorry, here's my x1, y1, and here's my x2, y2. Okay, so I'm going to go this x plus this x, that's what this says right here, over 2. This y plus this y over 2, okay? 4 plus -6 is going to get me -2, and then -4 plus 4 is going to get me 0, and those are both over 2. Okay, so now we're just going to simplify these fractions. Negative 2 over 2 is negative 1. 0 over anything is 0, so we get the midpoint to be negative 1, 0. Okay, all right, so now use those same coordinates to find the length, the distance. Okay, here's distance formula, another formula that I'm requiring you guys to know, because you're going to need that for IM2, 3, pre-cal, cal, all that stuff. Okay, again, the same. It doesn't matter which one you want to call x1, y1, and x2, y2. Doesn't matter, but these, I'm just, this is my x and this is my x, the first numbers, and the second numbers are the y's. Okay, so we're going to plug them in right here. So I'm going to go negative 6 minus 4, and then squared, and then add 4 minus a minus 4, and then squared. Okay, so that's what that is. And as long as you're doing things correctly, watch the negatives. Negative 6 minus 4 is negative 10, and then 4 minus a minus 4 is 4 plus 4, or 8. And so we get the square root of 164, and if you wanted to use your calculator and get an approximate answer, it's about 12.8. Okay, almost done. All right, so here's a vector that represents a transformation. Okay, so the vector is this guy right here. Okay, here's the vector right here. This vector goes down 1 to the left, looks like 4. So we're going to take this point, go down 1 to the left, I think it's 5, sorry, let's see. 1, 2, 3, 4, 5. So we got to take all of these points down 1 over 5. Okay, down 1 over 5. Same, all of them. Okay, so that vector goes down 1 to the left 5, so we've got to make all those points go down 1 to the left 5. Okay, all right, so there we are. Okay, so state the hypotheses and conclusion of the statement. If a plane contains two lines, then they are coplanar. Okay, well, the hypotheses, you guys, is what follows the if part, and the conclusion is what follows the then part. Okay, so what follows the if part? Just find the word if. Okay, if. So the hypothesis is a plane contains two lines. Okay, easy enough. And then the conclusion is what follows the then part. They are coplanar. All right, okay, so here we have angle ABC and angle CBD are a linear pair. Linear pair means that they just make up a straight line. Linear means line, okay? So angles that make up a straight line, they just make up a straight line, okay? And then it says that not only that, that they're equal to each other. So it says that okay, so angle ABD, B is the vertex, and angle, as I say D, AC, and CBD are a linear pair, so they make up a straight line. So B is the vertex where they make up that straight line, and they're equal to each other. Okay, so there's a straight line right there. Okay, so here's angle ABC and CBD, and it says that they're equal to each other. So if they're equal to each other, then these two angles must be both 90, because they add up to 180, 90, and 90 right there. So we can, since they're equal, they're both equal to 6x plus 6. Now what we can do is do this, you guys. We can do 6x plus 6 plus 6x plus 6 equals the whole angle of 180. That's the angle addition postulate. Or since they both equal 90, we can just set one 6x plus 6 equal to 90. Okay, so minus 6, whoops, and then, whoa, I went too fast, huh? Darn thing. Let me do this here. Okay, so minus 6, and then we're going to divide by that 6 from the 6x, and 6 goes into 84 14 times. Okay, and that's all it said. It said find x. It didn't say find the angles. We already know that they're 90 right there. Okay, okay, last part, you guys. State the property of equality that's being used in each. Okay, so here, you guys, it says if 7x plus 2 equals 51, just imagine, what would you do to solve for this equation? You would subtract 2 on both sides, and so that's how we got 49. So we used the subtraction property of equality. Okay, and then this one, you're going to see this one over and over and over again. It kind of goes like this. If A equals B and B equals C, then A equals C. Whoops, there should be an X right there. Okay, I'm going to put an X right there. I've got to have it straightened out. That's darn mouse of mine. this mouse. So anyway, so it should say 5x equals 3x minus 2. So that would be the transitive property when that's happening right there, okay? All right, you guys. Hey, I hope you guys do fantastic on your test that's coming up, and sorry about my mouse. It's clicking too much, okay? Good luck, you guys. Take care.